G'day everybody, I'm Scott Poynton and welcome to the first Sustainability Unpicked podcast. And I'm here today with Dr. Kat Bruce. How are you, Kat?
I'm very well, thanks.
And Kat, you work for a very fascinating company called NatureMetrics, is that right?
Yep.
Give us a quick story, a quick overview of what NatureMetrics does.
So NatureMetrics provides biodiversity monitoring, but using environmental DNA. So we take really complex biological samples with lots and lots of species in them and generate data sets that sort of give you an overview of the complete diversity in the samples.
Okay, now when I first heard about this was just recently, and I'm really grateful that you're here in the office here in Switzerland today and normally based in the UK, is that right?
Yeah, that's right.
Whereabouts?
We're just outside London, actually very close to Heathrow.
Very close to Heathrow. Okay, so I just heard about this a few weeks ago and here you are you're over for a visit, and so a great opportunity to catch up. What fascinated me about what you were doing was for many years we've looked at trying to verify what companies are doing in terms of their sustainability policies. And one of the measures, for example, is biodiversity, particularly in forest conservation, also in the palm oil industry. And one of the excuses that people have used, and it's a fair excuse to be fair, that it's quite expensive to send teams of people out into the forest, out into plantations to monitor what biodiversity is there. And as a consequence, they don't do it. You know, it's expensive, it's time consuming, they've got to get big teams out there, it's a whole logistical exercise to make sure they've got food and water. You send people out there with a plastic cup and start sampling water samples. How does it work?
Well, yeah, so the sampling method that we've come up with, we've developed to try and be as universal as possible. So the idea is that literally anyone can take a sample anywhere in the world. So you have a sort of a kit which has got a little plastic filter in it. And you just pull water up in a 50 milliliter syringe, screw it onto the filter and push the water through and repeat that as many times as you can. And all of the genetic material that's been in the water, in this case, is trapped inside the filter. And the water just sort of flows through and back out. And then you can just pop a preservative inside the filter and send it to the lab. And we can then extract the DNA from it and sequence it. And it's just an amazingly powerful tool to reveal what species have been living in and around the water.
So it's things like poo and things like that, and that comes from the animals, goes into the water, and you're able to capture it. Yeah,
that's right. So so a lot of it does come from fecal material and droppings. Poo, yeah. There's a lot of it comes from poo.
Technical term.
But also mucus, just shed skin cells,
dead bodies,
urine, dead bodies. So
you need that stuff to get into the water. And so I was thinking about this last night when I knew you were coming so if I'm out in the bush in Indonesia somewhere and I'm wondering what biodiversity is there, I might be in a forest where there could be tigers, for example. Mm-hmm. How far, around the stream if the tiger did a poo a kilometre away, will it get into the water eventually? I mean, is there any idea about? How much sampling do you think you need to do to try and get this sort of stuff? It's a bit of a technical question, but I was just fascinated to see. I'm excited by the results you're getting because I think you're getting vast lists of species in a very quick way and a very relatively cheap way.
Yeah.
But how does it work in terms of getting that overview?
So to give you a bit of an example, we've been doing quite a lot of work in the Peruvian Amazon recently, working with WWF Peru. And they've taken about 160 samples now, so 40 sites, and they've taken 4 samples per site. And each sample is just half a litre of river water. So these are from the big rivers in the north of Peru. And in those samples, now we've got a species list of almost 700 vertebrate species, of which more than half are fish. And the vast majority of the vertebrate DNA that we get is fish because they're living in the water, they're shedding DNA in sort of large and consistent amounts. So for the fish, the data are very replicable. And if you pick up a fish in one of the 4 samples at a site, you'll most likely pick it up in the other samples as well.
Right.
With the terrestrial mammals and other terrestrial vertebrates, it's a bit different. So you pick up just little tiny bits of their DNA here and there. So it's much more a sort of incidental detections.
Right.
And in any one sample, you can't rely on picking something up. It's as you sort of build that number of samples, you end up with sort of an overview. So And I think also the environment makes quite a big difference. So in the rainforest, one of the advantages is that it rains a lot.
Right.
So you have that sort of regular rainfall that's washing DNA off the land and into the water. We don't know very much about that sort of spatial aspect of the detections of the terrestrial fauna. And we were actually amazingly, we were really surprised at how much we did pick up in those samples. But I mean, we've got everything there from jaguars, giant anteaters, we've got all of the monkeys, we've got 25 species of bats, we've got, I mean, things like night monkeys that are so difficult to see because they're up in the trees and they're only active at night, but their DNA shows up in the water. So
it cost a fortune to do surveys to actually find this stuff, wouldn't it? Really?
Yeah. You'd have to send out teams of, of experts in each of the different groups that you're looking for. With this you can just get it with.
And it's a 1 or a 0, isn't it? I mean, if it's there, if you get DNA, then the animal's there. And so
or it's somewhere close by. So
somewhere close by, of course. It could have moved through, for example.
Yeah, so the sort of dynamics of DNA in the environment are quite interesting, actually, and something that is important to be aware of. So if you're working in running water in big rivers, then DNA travels downstream once it's released from the animal. So if you detect something, you know that it's sort of either there or it's somewhere upstream of where you've sampled. And we know that the DNA is viable for identifying species for about 48 hours after it's released.
Right.
So in a really big river, it can travel kilometres in that time, whereas in a smaller river, it'll be just a sort of few hundred metres and it'll be a more localised thing. Whereas we kind of have the opposite challenge in still water. So in lakes, what you find is that the DNA doesn't move very far from where it's released. So if you've got animals that are just using one end of a lake, for example, you'll find the species there, but not at the other end. Okay. So then we have to make sure we're taking representative samples. So you take subsamples of water from sort of along the edge of the lake and then merge them.
Okay. And you mentioned to me before that as well as taking samples of water, you can take samples of soil as well, right?
Yeah.
And presumably you're getting vast amounts of insects and all sorts of things in these samples as well. But I guess it depends on your DNA record to know exactly what's there, right? And that's being built at the moment too, isn't it?
Yeah, there's an ongoing effort. I mean, there's actually an ongoing effort at the moment to try and sequence the genome of every species in the world within the next 10 years. Whether or not that will realistically happen, we don't know. But what it does mean is that there's huge amounts of money being put into building global reference databases. So at the moment, if you're looking at European fish, for example, everything is really well referenced.
So you find a bit of DNA in a sample, you can pretty accurately tell which species it is because that reference work has been done. Yeah,
exactly. If you sort of move then away to somewhere tropical, so in Peru, for example, most of the mammals we can identify to species level, with the exception of some of the rodents and things that aren't in there. But then the fish, probably only 15 or 20% of them, we can put a species name on. The rest of them we'll be able to say, essentially this is a species within this family of fish.
Right.
And the nice thing is that at a later date, as the reference databases grow, we can go back to that data we've already got and add the names on. So you don't need to wait until it's a complete database to start surveying. You then end up at the other end of the scale from European fish is soil invertebrates and soil fauna and the microbes as well, because obviously you're picking
millions
those up. Yeah, and a lot of these things no one knows what they are, and nobody, in a way, it doesn't matter so much. So I think of biodiversity and I think of two strands of biodiversity. You've got your biodiversity as animals or species where there's some kind of cultural or emotional or commercial importance to what something is. And we need to know what it is, and we need to have high confidence identifications. And then at the other end of the scale, you've got biodiversity as data, where actually you're not worried necessarily about what things are. You're worried about how stable they are, or whether they're changing, or whether it's signaling sort of degradation in some way. And that end of biodiversity It's really much more suited to a sort of big data approach. You've got thousands of species in the soils, for example, that are responding to hundreds of environmental variables, and it's big, noisy data, but there's signal in it.
Gotcha.
So actually being able to, now that we can generate these data sets where we might not be able to name everything, but it's a really powerful, high-resolution data set, we can start applying some of those big data analytical techniques.
Gotcha. Makes it clear. So let's think about the application of this. I mean, for me, it's very powerful. I'm thinking of palm oil companies, for example, where they're setting forest aside to, as part of their forest conservation policy work. Verifying that forest is set aside is one thing, but understanding what's actually in the forest is another. And if these are empty forests, there's the whole concept of empty forests coming as we're losing so many species. I wouldn't say it's a pointless exercise because the trees and the plants might still be there, but for a period of time, because a lot of them need animals for pollinating and things like this. But I'm fascinated to know from your thoughts on where this could be applied, because for me, palm oil industry, timber industry, obviously I'm forest oriented, but I could see this applying in all sorts of contexts. And what do you think the future for the technology is?
So I think broadly one of the strongest uses for this sort of technology is in the sort of environmental impact assessment and environmental reporting world. I think the ability to build really sort of good high resolution baselines quickly and not too expensively is a bit of a game changer, because then you've got something that you can measure against over time, whether that's measuring what your impact is and how well you've restored habitat afterwards.
Right. There's a lot of habitat restoration going on, and people want to get a sense of how that's going.
Exactly.
This seems to be a quick and easy measure.
And and it's something that actually a lot of people should be reporting to funders and
their customers, stakeholders and things like this. People have got these policies, they're saying they're protecting forests, and I think people want to know, well, how's that going? And if you had a measure to be able to say, well, look, last year we had this many species and some key species, here they are. This year we've got more. And it gives a sense of recovery.
Yeah. So that, you can see it as a tool that can help to hold people to account for the impact that they have on the natural world, but conversely also, it's a way of people actually being able to provide evidence to show when they're doing good work, and that makes that investment worth it. And it also, the adaptive management has been held up as this sort of gold standard, where you see your management interventions as a hypothesis and you adapt them to improve over time. But actually, to do that, you need information, you need data to make those decisions based on. So actually, it's been a very difficult thing to implement. But with this, we can measure regularly and routinely, and all of that information can then be used to improve the way that we manage the environment and to understand and learn.
I love it. So just quickly, tell me about NatureMetrics. When did that start? What's the origin of that?
So
tell us about yourself. Yeah.
So I was a tropical ecologist by training, and I spent quite a lot of time in the Peruvian Amazon. Completely by chance, we've ended up working back there. And during my PhD, I started using DNA-based tools to be able to generate data, actually mostly on insect communities, because again, you can collect insects in thousands easily, right? And then we look at them and go, we've only got someone who can identify beetles and butterflies, so we'll ID those and throw the rest away, and that's all data. And so rather than doing that, we can just, with the insects, you literally sort of squish them all up and sequence their DNA, and you can sequence 100 big trap samples in parallel all together in a single reaction. And you generate these data sets at scales that have just never been there before.
Pretty cheaply, right?
Pretty cheaply. So it's, a couple of $100s per sample.
I mean, it's ridiculous, a couple of $100.
And
to get a massive data set of the invertebrate population.
Yeah.
I mean, imagine what that would cost in terms of a field crew going out to gather that information, and then the analysis afterwards.
Yeah.
That's really where it comes, isn't it?
It's the analysis afterwards, and the fact that, if you've got people identifying these things, then it's the cost scales with the number of samples. If you've got 100 samples, it takes 100 times longer than one sample.
Right.
Whereas with this, we can do everything in one go. So,
and just an aside, I mean, we're hearing about, insect Armageddon around the world, and, it just strikes me that what you were talking about with big data, understanding how many insects and the diversity of insects, maybe not just the diversity, but the different families of insects that are in a sample, for example, within a palm oil plantation or within a forest, within an agricultural field, for example, could start giving you a sense of direction, like actually, you know what, we're losing a lot of these things.
Because otherwise you get what's happened now, where people don't notice until you suddenly go, hold on, our car windscreens aren't covered in insects anymore like they used to be. And you realise we've lost 70-80% of the insects.
Late.
And it's too late. And, we could have caught some of those trends much earlier. And if you look at things like the State of Nature report and things, they always pick out the invertebrates as being the big data gaps. We just don't know what's where. So we were using these tools. So the key tool we use is something called metabarcoding, which is where you take a mixed sample and sequence it all at once. And we realized that a lot of really good research was being done that was really providing excellent proof of concepts of these tools. And they would be written up as papers, and the last paragraph would sort of say, this is going to change the world of environmental monitoring, and solves all of these challenges. And then it would be published in a molecular journal.
No one would ever read it.
No one would ever read it. So we were going around talking to environmental managers, and they were saying, we thought these tools would be something that might be there in 20 years' time, but it's not there. They're here. And we set up NatureMetrics really to bridge the gap between the research world and the environmental managers who might want to use these tools, and turn them into something that was accessible and affordable for routine use. So I've been working on it one way or another sort of since 2012, but we set up the company and actually started commercially trading in 2016.
Okay, so short period of time, really. Team of how many?
So we've got 12 at the moment. 12,
yeah. And I see also that you're developing partnerships with labs around the world so that all of the samples don't have to be sent home to the UK.
Yeah.
How's that going? That'll make it more accessible too.
Yeah, it will do. And it's going to be a challenge to get it all set up sort of robustly and maintain the same. Make sure we maintain the same quality of service that we do at the moment in the UK. But one of the challenges is always that it's very difficult to export biological samples from a lot of countries.
Of course, yes.
And we actually want to go and have a positive impact in the countries where we're doing a lot of work. So sort of building capacity and skills is important to us. And we've got citizen science kits that we can engage with local communities and NGOs and conservation projects in those countries as well. So we've got a lab already in Peru. We've partnered with a lab called BioAl and trained them up to process our water samples. So far it's going well. So far going well. And I know you're looking at Indonesia as well. Mm-hmm. Yeah, I mean, I think this could be a great resource for the palm oil industry. I really do. And for those companies in the palm oil industry who want to really prove that their management's having a positive impact at a reasonable cost. Mm. And I think really the cost and the logistics has been a barrier for them, but I think that barrier has just been removed. You guys are doing it. I mean, the thing is people have been spending quite large amounts of money as well on biodiversity assessments, right, often getting very little useful data for it or not getting it within the time frame. Turns them off doing it. Yeah, exactly. So being able to, make it more accessible for people who haven't been able to do it because of the cost, but also being able to, greatly just improve the quality and quantity of data that you get for the bigger projects that are spending money on it already is, it could be potentially a game changer. I think it will be. Well, thanks so much for coming and talking to us about it. You're very welcome. Thanks for having me. Yeah, no, we'll try and share the story as broadly as we can because I think what you're doing is a game changer and could give us a great load of information that we're currently seriously lacking, as you say, until the insects are no longer at our windscreens. Mm-hmm. So, Kat Bruce, thanks so much for joining us. Thanks, Scott. That was Kat Bruce, the CEO, is that right, Kat? That's right. CEO of NatureMetrics, a fascinating science-based company out of the UK that's doing great work all around the world. And that's our first Sustainability Unpicked podcast, and there'll be a lot more. I'm Scott Poynton. Thanks for joining us.